Hi everyone, this is MathsForUni. This is the work solution to question 6 from lecture 5. If you enjoy this content, then please consider liking and subscribing, as well as checking out our Udemy course, of which the link is in the description. The question says, find the value of x mod 5 such that 2x is congruent to 3 mod 5. Now here the numbers are sufficiently small that we can just check all of the cases. X is either congruent to 0, 1, 2, 3 or 4 modulo 5. In the first case, which is x being congruent to 0 mod 5, we have that 2x is also congruent to 0 mod 5. Next we have x being congruent to 1 mod 5. Well then 2x is congruent to 2 by multiplying mod 5. Next we have x being congruent to 2 mod 5. This gives us that 2x is congruent to 4 mod 5. Again, we're looking for 3 here as part of our equation. Next, we're looking at x being congruent to 3 mod 5. Here's where things start to slightly change. We have 2x is congruent to 6 mod 5, but that's really, in this range, 1 mod 5. The last case, before it wraps back around to 0, is x being congruent to 4 mod 5. This gives us 2x being congruent to 8 mod 5, which is 3 mod 5. This is the equation that we had above, and therefore the value of x mod 5 must be 4, i.e. the solution is x is congruent to 4 mod 5. You should think of these as a collection of possible solutions, i.e. all of the numbers that have a remainder of 4 when divided by 5. So 4, 9, 14, 19, and so on, but also in the opposite direction, -1, -6, -11, -16, and so on. When the numbers are larger in the equations that we have here, there is a more consistent and systematic method to solve modular equations such as these, which involves finding the inverse of this 2 that's here modulo 5. Again, imagine that the numbers, say here, here, and here, were larger. Have a look at Euclid's extended algorithm for such a method. If you've enjoyed this video, then please consider liking and subscribing, and also checking out our Udemy course, of which this example is part of. Thanks for watching, and goodbye for now.